can't just assume that all continuous distributions are normal. So before we start making assumptions about probability and things, it is important to evaluate if that distribution is approximately normal. So normally distributed data should approximate that theoretical normal distribution. So here are those characteristics. The normal distribution should be bell-shaped or symmetrical, where the mean is equal to the median. The empirical rule applies to the normal distribution. So you have that 99.7, 95, 68% rule. The interquartile range of a normal distribution is 1.33 standard deviations. So those are the characteristics of a normal distribution, and other ways we can determine if it is normal is we can look at charts or graphs. So for small or moderate sized data sets, you want to construct a stem and leaf display or a box plot to make sure that it is symmetrical. And then for larger data sets, we can use a polygon or a histogram and see if it looks kind of bell-shaped. We can also compute those descriptive summary measures. So the mean, the median, and mode, do they have similar values? That theoretical normal distribution, they should all be the same. And is the interquartile range approximately 1.33 standard deviations? And is the range approximately 6 standard deviations? We can also look at the distribution of the set. So 2/3 of the observations should lie within 1 standard deviation of the mean. Approximately 80% of the observations should lie between plus or minus 1.28 standard deviations of the mean, and 95% of the observations should be within 2 standard deviations of the mean. We can also look at a normal probability plot, and I'll show you some examples of normal probability plot on the next slide. But the normal probability plot should be pretty straight, approximately linear, with a positive slope. I'm not going to ask you to construct a normal probability plot, but here are the steps to construct one. You first want to arrange that data into an ordered array and find the corresponding standardized normal quantile values. Then you're going to want to plot the pairs of points with observed data values on the vertical axis, and then the standardized normal or the z values on the horizontal axis. And like I mentioned earlier, you want to look at the plot to see if it's a positive linear plot. So here's an example of that normal probability plot. It is approximately linear and it's also positive. Nonlinear plots, we can also make assumptions. So if it kind of has a curve upward, it's going to be a left skewed distribution. If it kind of curves downward this way, it has a right skewed distribution. And if we see kind of this S shape here, our distribution would be more rectangular. So if it's not a straight positive line, then that kind of indicates a deviation from a normal distribution. As I mentioned earlier, we can also look at box plots to determine if something is symmetrical. So from the previous chapters, we know that this distribution is skewed to the right, and this is not a normal distribution. We can also look at descriptive statistics, and just looking at the mean, the median, and mode, they're all about the same, so we could conclude that it is a normal distribution. However, if we look at the other statistics, that might not be the case. So the range is equal to 59.52, and that's equal to 9.26 standard deviations, and we found that by using how many standard deviations right here fit into that range. So in a normal distribution, that range is 6 standard deviations, and this seems to be a lot larger than that. We can also look at that probability plot. So this plot isn't a straight line, and it actually kind of swoops a little bit downward. So this appears again to be skewed to the right. So again, we can't just conclude or assume that all distributions are normally distributed, and we have to actually evaluate that. So here in the past couple of slides, we've seen that those returns are actually right skewed. The range was much larger than we expected and that differs from a normal distribution. And if we're looking at that normal probability plot, it is not a straight line. So we can't say that this is a normal distribution and use those assumptions to make probability statements. So in this chapter, again, we looked at computing probabilities from the normal distribution and using the normal distribution to solve problems like the download speed examples that we looked at. And we also looked at how to evaluate normality. So that's the end of chapter 6. Thank you for bearing with my raspy voice here. Please let me know if you have any questions.